morning, students. I am Jeevan Kumar Pandey, and we have started in our school the online classes. So this will be your students' first lesson on electrostatics. The first chapter given in your textbook is electric charges and fields. Though this is a vast topic, but in the first two chapters, we shall be basically discussing about electrostatics. Statics deals with the study of objects at rest. Here we don't deal with the objects, rather we discuss the charge on them. So the branch of physics that deals with the study of charges at rest is called as electrostatics. This is not a very new thing for you students. The term electron, in fact, was coined from amber. You might be knowing about this. Since long ago, we know that some materials like amber, when rubbed against some object, suitable object, they on rubbing develop a property of attracting small bits of thermocol, paper bits, pieces of plastic, etc. We say they have got electrified and they have developed some charge. I am damn sure all of you must have played with this little activity of rubbing something against your hair, most preferably ruler scale, plastic scale, and then trying to attract bits of paper. Though it is quite childish, but there is a lot of physics involved in that. So I'll begin this particular chapter with this activity which you everybody know, and today I am demonstrating, but I don't have a plastic ruler. Instead I am using a PVC pipe. So students, if it is rubbed against dry hair, it attracts bits of paper. You can see over here some paper bits are there. Oh, excellent! You can see it has formed a pile, a mountain of paper bits. So we say it has got electrified, it has developed some charge, and it can lift it. Now this might not be very much interesting for you, but I would like you to think a bit one step more. We say this PVC pipe has got electrified, it has developed some charge, so it is attracting bits of paper. Of course, how does it attract a neutral paper? That is again a big question, because the paper was not charged. But that we will be answering after a few lessons. But one thing I would like to suggest, class 11th you have read about free body diagram. Now concentrate only on that paper bit. On this paper bit, if I ask you, which are the forces acting? What will be your answer? Think for a moment. So if this is the paper bit, it will have some mass, say m. One force is for sure its weight that acts in vertically downward direction, and that is mg. If there were only one force, it would have fallen down, but it is at rest, sticking to this PVC pipe. So what is the other force, students? Could you get it? I hope you have got the answer. That other force is in upward direction, and that is exerted by this PVC pipe, and that is force due to the electrical charges. We can call it as electrostatic force. And of course, since its acceleration is zero, both these forces must cancel. Net force on this paper bit must be zero, and therefore we must write that the net electrical force which is in upward direction must be equal to the gravitational force in downward direction. Then what's so important about this? You remember I told you to think a bit deeper. Now here comes the interesting part. Who exerts this gravitational force? Obviously, it is the Earth. What is the mass of the Earth, do you know? It is 6 into 10 to the power 24 kg. The entire Earth exerts some force in downward direction that is equal to the weight of the paper. That much force exerted by the entire enormous mass of the Earth is balanced just by a small segment of this PVC pipe. How? Just by rubbing it. That means the force exerted by this PVC pipe on this paper bit is equal and opposite to the force exerted on this paper bit by the entire Earth. And that concludes. Of course, we will discuss later on in properties of charges, but one thing for sure you can say that, very important, electrostatic force, electrical forces are very, very large compared to gravitational forces. There are many similarities between these electrostatic forces and gravitational force. Gravitational force we have already read, but there are many dissimilarities. Among those, one dissimilarity is this, that electrical forces, as I discussed, are quite strong compared to the gravitational forces. You might wonder, when I am standing over here, while watching this video, you would be sitting, sleeping, lying in a bed or a sofa or chair. What forces govern your position? What forces govern my position? What forces make this particular board lying against the wall? What forces are responsible for this? If you try to answer most of the questions related to forces in and around you, macroscopic world, from few millimeters to several thousands of kilometers within the earth, you will find most of your answers will be electromagnetic force. When you shake hands with your friends, you are exerting electrical forces, magnetic forces. But when the distance grows, for example, between our Earth and Sun, the dominating force is the gravitational force. Try to think about this question, why does that happen? Why Coulombic force or electrical forces between Earth and Sun is not dominant over the gravitational force? The rules of the universe are mostly governed by gravity. Why is it so when I am saying that electrical forces are greater than gravitational forces? Assignment number 1. Think over this question, try to find the answer. Okay. We'll proceed further. These are the things which we shall discuss today. Types of charges. We'll have a small discussion on electroscope, a small discussion on conductors and insulators, meaning of earthing, and some methods of charging by induction and conduction. Types of charges. Just now we saw some activity wherein I charged some PVC pipe against my hair and it got electrified. Here I have an ebonite rod and this is a glass rod. When rubbed with suitable materials, they also can get electrified. Ebonite rod, if rubbed with fur, develops charge. So one more thing, students, just now I demonstrated you one activity that by rubbing against your hair, you must have lifted pieces of paper, but with the same activity, I have to do something more dramatic. You might think that paper bits are very light, so it's easy to attack them. In front of you, over here, I have a meter scale. You can see this is one wooden meter scale. It's quite heavy, and in fact, I can feel this scale is as heavy and slightly heavier, I think, than this PVC pipe. I'll put this scale, I'll try to pivot it onto a lens somewhere at the center, like so. Let's see whether the charge developed over this particular pipe is sufficient enough to attract this heavy meter scale. So I am rubbing against my dry hair. One more thing, students, when you perform such activities, the best suitable situation for performing such activities is in winter season, a dry weather. On a dry day, it is most efficient. So let's see whether we succeed or not. I'll just bring it close to the end of the scale, and you can see, oh, it starts attracting this from this side. Again, you can see I am not touching it, but it starts moving. And so enormous is the force of attraction that the entire scale starts oscillating. It's a very simple activity. You just need and not necessarily a scale. If you have a wooden bar at your home, you can try it to fix it over a pivot it over a convex surface, and then you can perform this activity. Next, as I told, we shall discuss types of charges. One thing for sure, if there is a neutral body, we say the net charge on it is 0. This ebonite rod, when we rub against fur, like so, we say it gets electrified. It develops some charge. This ebonite rod, of course, the attraction is feeble, not as good, but you can see, yes, they are attracted. This ebonite rod acquires, we say, negative charge. Contrary to this, a glass rod, when rubbed against silk, we say it acquires positive charge. You can see it has also got electrified. The paper bits are attracted. But you saw that when this ebonite rod and this glass rod, I rubbed them, both of them got electrified, both of them attracted the bits of paper. So we say they developed charge. But how do we decide that they have same type of charge or opposite type of charge? For that, I have another model that we basically call it as Venn diagram generator. And at this point of time, I would like to give credit to one of my students, Master Pritam Kumar. Like you, he was also a student of Class 2 of DAV Gumla, and he had made this particular device. Here you can see there is a metal can. This is the metal can suspended over a PVC pipe. There is a belt over there. Here also there is a PVC pipe, and a wire runs from this end to within the can. And on this can, some insulating balls, thermocol balls, which we say, hang using simple thread. When I turn this belt, it rubs against this PVC pipe, and just we saw, as in case of other cases of rubbing, here also frictional electricity causes static charges. Those static charges force the electrons over this wire to move and make this particular can negatively charged. And those charges result in repulsion, which I will try to show you. Observe it carefully. Ho ho! Could you see this? Excellent! I once again thank Pritham. He has made this excellent model. I like this model so very much that I have kept it, preserved it, and his generosity, it is now being used to demonstrate some activities to other students. I think this is a thing which should inspire you. Excellent. You can see they are getting charged. Okay, let me try to have some more charge. You can see some of them are repelled more, some others less. And as I told, these activities will perform the best in which weather, students? In dry weather. So this is not worst, this is not the best also. If we were doing this in winter season, I would have expected a better result. Let's see now, how do these rods behave? Remember, this is negatively charged. I bring this ebonite rod. Now before I do so, let me remind you that glass rod on rubbing acquires what kind of charge? Positive. And ebonite rod acquires what kind of charge? Negative. If it is so, let's see their properties as far as these balls are concerned. I bring this ebonite rod and you can see some repulsion. Could you see? It is repelling the ball. Why? Because it is negatively charged and this is also negatively charged. Let me provide some more charges to it. Oh, it didn't work quite well. No problem. Let me try this end. Remember students, whenever things don't work, don't be embarrassed. I am not embarrassed because that teaches you one thing. That teaches you that the laws of physics never go wrong. What goes wrong are the essential conditions. The essential conditions required to be put over here were not met by me and other situations over here. So never worry. Let me try it once again. Yes, excellent. You can see the repulsion. Now, I know you are very inquisitive and you will be happy to know that what you are thinking is in fact correct. Glass rod, silk, positive charge. We should expect what? Yeah, attraction. You can see how that ball wants to come close to the glass. Isn't this very enchanting? You can see these balls. All these balls want to come close to the glass rod. In fact, whatever insulating materials and some conductors you have, rubbed, unrubbed, when you bring them close, you can see, please note carefully, I will try to bring my palm, my skin, close to this. Observe carefully. Did you see something? Could you see there is some attraction? Was my body charmed? I don't know. If it were neutral also, it would have been attracted. Let me put some more negative charge. At this junction, let me show you one more interesting thing. This is metal. I am touching it like this. I am grounding it. Of course, grounding, I beg your pardon, I have not yet discussed. I will discuss it in the next section. It is neutral for sure. Let me bring it. I brought positively charged glass rod. I brought negatively charged ebonite rod. You observed attraction and repulsion. Question. What would you observe if I bring a neutral body of metal close to this Venn diagram generator? Think for 5 seconds, 10 seconds. Let's see. Oh, it is attracting. To my surprise, how does it attract? Neutral body. Excellent, you can see. And note one more thing. I am just now discussing conductors and insulators. This is a conductor, this is a conductor. This was an insulator. If you are a very keen observer, you must have noticed something. Of course, one thing, it attracted, although it was neutral. Remember students, neutral bodies can also attract a charged body. Lesson to be learned. Very important and remarkable statement. I am feeling restless to give you the explanation, and that what I am going to explain now is something related to induction. What happens when you have a charged body? See, how do I create the negative charges on them? When I bring a neutral metal, metals and insulators. Metal is a conductor, this is an insulator, glass. They differ in one important property. What is that? They do not have free electrons. Who? Insulators. But metals, they have number of free electrons. When I bring it close, since this is negatively charged, it will repel the electrons over this. The electrons will move. They will be repelled. So this side will be deprived of electrons, and the electrons will go and accumulate at this position far from those negatively charged balls. This is negative, it repels the electrons, electrons come to this side, so this side will become positively charged because it is losing electron, this side will become negatively charged. Between negative and positive end, there is attraction. This negative end and this negative end, there is repulsion. But because this distance is close, short, attraction is more, and that's why there is some attraction. And that's why it attracts. Note that till now I have not touched. The moment I touch this can, you see something will happen. They all fall back. Why? Negative charges, because it allows the flow of electrons. They flow through this metal, which is not possible in case of insulator. See, the glass rod was also attracting for another reason. See, I'll touch it. I have touched it, and then I'll remove it. It did not fall. I'll touch it. I'll remove it. It did not fall. I'll touch the metal can also. Nothing happens. Why nothing happens? Because the charges over the metal can, they cannot flow through this insulator. And that is the important difference between conductor and insulator. Try to do these activities at home, students. They are quite enchanting. The moment I touch this metal with the metal can, observe carefully what happens to these balls. What happened? Yes, you are right. Those extra electrons, they flow from the can to the metal, to my finger, to my hand, and to the earth. This is called as earthing. See, from one simple thing, you understood what are the types of charges, how a conductor and an insulator vary from one another. One of them allows charge to flow, another does not allow charge to flow, and what is the meaning of earthing. Let me explain to you the meaning of earthing. Whenever there is charged body, like so, earthing in class 10th we have read, it is a safety measure. In your homes, I'm sorry I can't show you over here. You have three pins. One is live, one is neutral, and one is earthing. That metallic part of any appliance, for example, here you can see some metallic part. I'll show you afterwards. This one. The metallic part of any electrical appliance is connected to the earth wire that goes deep into the ground. Excess charge. For example, here now there is some excess charge. This excess charge, if you touch this skin, now I was touching it with a metal. Remember, our body itself is a fairly good conductor of electricity. Observe carefully what happens. I'll touch this can with my finger. Could you see? I'm sorry, but please try to be very calm and try to listen some cracking sound. I'll bring this close to the recorder. Let me charge it first. So students, forget about the definitions. This is called as earthing. Whenever we have extra charge piled up over a metallic surface, if you give some path to it, whether it is a wire, whether it is a human body or some other conducting material, any conducting path you give it to flow to the earth, that will be referred to as earthing. Of course, you can find better definitions in your textbooks. Please make the notes of all these things which I am discussing. I'll bring it close. I want you to hear some cracking sound. Now I'll touch it with my finger. Try to listen to that cracking sound. It was very feeble. Let me try it once more. Yes, there was a cracking sound. Similar sound you hear, particularly in winter season when you take out your woolen garments, you hear cracking of your uh, hairs on your palm, particularly in winter season. That's because your body has got sufficient charges, and when you happen to touch some metallic surface, there is some discharge. Exactly in the same fashion as there was a discharge from here through my body to the earth. This is called as earthing. Earthing, uh, it can be done, it can be, usually you have a wire like so. Let me show you. This one. This one is the earthing terminal. Any electrical appliance, the metallic part is connected to this particular terminal. Whenever excess charge, if by accident develops through this, as the charge flew through my body to the ground, likewise this part and the wire will go through the internal connections in households. It will go deep into the earth. That is the purpose of earthing. Now, before I proceed further, students, let me recapitulate what we have discussed so far. First, we discussed some historical background regarding electron, amber. Then we discussed types of charge. What kinds of object and develop what kind of charge. Then we discussed about earthing, and in brief we discussed the difference between conductors and insulators. There is one more thing which I would like to discuss, that is electroscope. Electroscope is a very simple device everybody can make, and it will take not more than 1 minute. In fact, it is simply a conductor, aluminium, copper, you can take any metal. Over here you can see this is a electroscope. Of course, the picture may vary from books to books. As simple as possible, understand the concept. Basically, it is a conductor. Here I have a wire, and at the bottom, let me show you, there are two foils made of aluminium. I hope it is clear. These two foils, aluminium foils, are also conductors, and they hang from there. This particular device or setup can be used to detect charges. Now let me first bring ebonite rod rubbed with fur. This is ebonite rod. We have discussed already that it will develop what kind of charge? Negative. If I bring this negatively charged rod close to this metal, what will happen? Being negatively charged, it will push the electrons over here. These electrons will be repelled and they will flow down through the wire to the foils of aluminium. And both the aluminium foils will become negatively charged. They will have excess of electrons. And if they become negatively charged, they will repel each other. Like charges repel. Let's see. I'll try to bring it close. Could you see they repel each other? Yes. There is a repulsion between them. Let me bring it close to. Now this repulsion, what do you expect would happen if I bring a positively charged glass rod? Let me try to induce some more charge, first negatively. Okay. Now I'll bring glass rod rubbed with silk. Now they are negatively charged. When I bring this glass rod, which is positively charged, it will attract the electrons. Remember, in the first step I had told the electrons were pushed down. But being positively charged, it should attract the electrons. If it attracts the electron, it will take the charges away. And if the charges are pulled out by this rod, you should see that the divergence of those two leaves of aluminum foil should decrease. You can see. Oh, it didn't work quite well. No problem, students. As I told you earlier, I failed once again to meet the requirements of the nature. That troubles me sometimes, but then nature does not care. Yes, they are repelling. Let me bring negatively charged. Yes, that was excellent. So let me first charge it positively. I'll touch it. I'll touch it. I'll touch it, and you can see the leaves flying apart. Now I'll bring oppositely charged rod. I'll rub it. It should decrease the charge on the aluminium foil, and therefore the repulsion should decrease. So let me see. Oh, it's getting charged. Probably it's getting discharged. Oh. Sometimes it works. I think I'll leave it here, students. By the way, let me tell you one more thing which accidentally happened here. I had put this hole quite close to the periphery. What happened just now, actually I'm telling you the reason. This aluminium foil got attracted to this plastic, which should not have been the case. It was so close that it got attracted, because this also can attract the charges. Anyway, this is a gold leaf electroscope. The name is coincidentally gold leaf electroscope. In the actual setup they use gold foils. It will work quite fine. You can try it at home also. It didn't work. It worked once, but it didn't work as per my expectation. Before concluding today's class, last thing which I would like to discuss is charging by induction. For that, this we have already discussed. It gets negatively charged on rubbing, and I will now bring its big brother, that is this. That is the actual Van de Graaff generator. It is its replica. Believe my students, I am more fascinated about this one than this one. It is a low cost, handmade, and most pleasing thing that it was made by a person just like you. So you can also make such things. Akshat, that's the problem in working from home. Let me first check the power. Here also it gets charged due to rubbing. That charge gets piled up over this dome, that is metal. First I will discuss charging by conduction. Charging by conduction means that metal simply you touch it. There are some Van de Graaff generators which create positive charge. There are some which create negative charges. Here this particular Van de Graaff generator, it creates negative charges. So by conduction, if it is negatively charged, the excess electrons will also flow to this particular metal and it will get negatively charged. If it were positively charged dome, then electrons will flow from this to this. Is it clear, students? So first method, that is conduction. Conduction, that is called as charging by contact. So here, as I showed to you, there is a metal, spherical metal. Suppose it is negatively charged. The charges, of course, you will learn afterwards, the charges reside on the outer surface of the metal. If I bring another metal in contact, this was metal A, this is metal B, and they have insulating supports. This is insulator, so that the charge does not flow out. So these electrons will, the excess electrons will also flow to the other metal. This also gets negatively charged. Likewise, if it is positively charged dome, and you bring it contact to another metal surface, that will also become what kind of charge? Positively charged. So this is very simple. Charging by contact. During charging by conduction, the sphere B, the second sphere, will develop same kind of charge as the first sphere. So let me repeat it. First of all, I think I should show you that yes, in fact, it gets charged. I am neutralizing it. See, I'm again neutralizing it. If it is uncharged, it should not show any attraction. That means it is charged still. Let me. So what I am doing now, I am allowing the charges to flow down to the earth through my body. Same for this. You can see there is no appreciable attraction. Let us charge it. I expect this to be charged, but I don't see any appreciable attraction. So probably some more. So let me check it out. Did you hear some cracking sound? I'll discuss about those cracking sounds later on in this session. It is attracting, in fact. Probably we will need to supply some more charge. This dome actually acquires negative charge. First time when I tried, probably sufficient charge was not accumulated. I am charging both of them. You can see there is a repulsion. From so very far also it is repelling. You can see. Observe this pith ball. Let me charge it some more. It is repelling. See. And as I move far, it becomes charged. It is negatively charged. Do you remember that? And I bring this metal. You can see. From such a far distance, it is experiencing the force. See how it settles down calmly. And again it attracted. Assignment. Why did it attract? And again it left it. Assignment. This was charging by contact. Remember, I am discharging it. This is still charged. And this is also charged negatively. And I can show you that it is negatively charged by bringing this. See. Could you see? Again, same reason. There was a discharge which you could not see, and now because it is charged, it might attract these. See, this is also attracting now. It's really very enchanting. This will also attract. You can see. That means that dome is still charged. This is also charged. Okay, now we will discuss charging by induction. Let me discharge it. This I have discussed, it is negatively charged. In induction, I will bring this metal sphere close to this but not in contact with this. So I will bring it close. Because it is negatively charged, it will repel the electrons over here, so they will go to this side. And because this end loses the electrons, it will become positively charged. Then, keeping it in close contact, I will touch the opposite end. This end I will touch. Touch means earthing. Earthing means, I have told you students, these charges will flow down to the earth. This is the symbol of ground or earth. First I bring this close without contact. So now we are discussing induction. Without contact, there is a gap between them. It develops opposite polarities. Other end I will discharge it, so it will lose the charges. So we will have a situation like this. So these charges will flow down to the earth. So here we will have positive charge. This is insulator. This is A, this is B. This is A, this is B. And then after earthing, we will remove the earthing. When we remove the earthing, because of the attraction, these positive charges will remain here. And then we will separate it. We will take it far. This is A. We will separate B quite far. The charges will distribute uniformly and we will get what kind of charge, students? Positively charged. One important thing you should pay attention, students. While I discussed charging by contact, I was touching this. Whatever charge this body has, same charge is acquired by this body. But in induction, opposite is the case. This is negatively charged dome, metallic dome, but by induction we are getting a positively charged sphere. Let's see how to do that. I'll wait for it to get some charge. First step, I'll bring it close. And I will earth it. Other end I will earth. There was a shock, if you could see. Then I'll remove this. And then I will take it far. This right now has acquired positive charge. This has a negative charge, this has positive charge. You can see it is attracting. If it were neutral, it should not have attracted it. You can see attraction. Because it is positively charged, it polarizes those pith balls. Again, this is a new concept which we will discuss afterwards. And you can see how they get attracted. And when I charged it by contact, induction, it got negatively charged. That time I had shown you, it repelled those negatively charged pith balls. Right now, students, let me show you. This is negatively charged. This is positively charged. If I bring it quite close, there might be a spark. And I would like you to see that spark. Akshat, please put the light off. Please put the light off. If you are lucky, we'll see it. Oh, could you see that? I can show you that spark. For that reason, I have made it dark. Please bear with me for some time. I have again operated it. Even if I bring this to neutral state, the other sphere which I was bringing, even then there will be some discharge, because the potential on this Van de Graaff is of quite high value, which we will discuss later in this particular section. I am bringing it close. Oh, could you see that spark? Let me try it once again. That was very feeble. Anyway, students, I'll stop it over here. Akshat, please put the light on. At least you can hear a cracking sound. You might hear. I heard it. It was feeble. So students, I'll end up today's discussion. Before concluding, let me ask you to do some assignments. Whatever concepts I have discussed, please see this video, recapitulate them, understand them, make notes of them. Whatever these topics I have written, have the practice of writing note, consult only one textbook. All these things I am discussing from the NCERT. Make your notes. You will have some doubts. We will discuss it afterwards. I'll put some assignments also in the website. So please try to solve those assignments. What I have discussed here, the method of induction, is not the case of example which is given in your textbook. Let me, for your reference, tell the page number. Page number 6 and 7. You will find two examples. One I have discussed, other I have not yet discussed. I will probably discuss it in the next class. So this I have discussed one of them. You will write that example. Other one, you try it yourself. If you have some problems, I will be discussing it in the next class. And next class we will start with properties of charge and Coulomb's law. I thank everybody who is watching this particular lesson, and I pray to God all of you while watching this video are in good health, sound health. Please utilize your time, stay at home, stay safe, stay healthy, be inside home, and utilize your time to the fullest capacity to study sincerely. Thank you, students. My blessings are with you. Thank you.